This is our last lesson on polynomial functions, lesson 3.4, and we will continue to focus on the shapes of the graphs, the zeros, the behaviors around the zeros that indicates multiplicity, and so on. The instructions tell us to find all the zeros, but we're going to do it just by using the graphing utility and possibly, if we need it, some synthetic division to depress the polynomial. The instructions say to use the rational zero theorem and Descartes' rule of signs, and we're not going to do those. So the first thing I want to do is put this function into my grapher. I'm having a little trouble with my grapher, but hopefully I have it in there. If you need to pause the video to put it in, that's fine. I have a window set at -10 to 10 for the x's, -75 to 50 for the y's. And I get this as a graph. All right, looking at this, I have y equals 0. It's the red horizontal line along the x-axis. I have that in there. So I can do second calc intersect, but I see a 0 at -2. I see a 0 at +1, and I see a 0 at 7. I could also, if I think those are right, but I'm not 100% sure, I can always go to second of graph, which is table, and type in -2, and I get y1 is 0, 1, I get y1 is 0, and 7, I get y1 is 0. That shows me that these x values give you y is 0. That makes them the zeros of the polynomial function. I used exclusively the graphing utility. Let's look at number 2. Going into the y equals, I'm going to clear this out. I have x raised to the 4th power, go to the right, subtract 14 x to the 3rd power, go to the right, plus 34x squared plus 114x plus 65. Now I think that I'm going to have a pretty extensive window here. I can see that the y-intercept is going to be 65. What should I be looking for? I should be looking for something with in behaviors of up and sort of like a W. So I doubt that I'm going to get a good window on my first try. I'm going to go ahead and go -20 to +20 for the x's. And for the y's, I think they're going to be much, much larger and smaller. I mean, much larger, much smaller. All right, I'm going to go -200 to +200. And I'm just choosing these numbers kind of randomly. I do know the y-intercept is 65. This is probably not going to give me the picture I need. Remember, thinking about a W. Well, what do you know? All right, not the worst thing in the world. I definitely don't need to go this far down, but I need to go further up. So back to window. I can simply do, say, -20 up to about 500. All right, this is not a bad window. I'm going to grab this and put it over here. I have zeros right here and I believe it to be multiplicity 2. In other words, I believe that in this picture, whoops, well, I was going to move it, but perhaps I can't, that I have x equals -1, and I believe it is multiplicity of 2. Now, how many total zeros are there? There are 4. I have just accounted for 2 of them right here. -1, -1, but I only write it down once. So I'm going to give myself a little more room and show you what we will do now with synthetic division. I know that x equals -1 is a double zero, multiplicity 2. I'm going to use -1 and synthetic division on 1, that's the x to the 4th, minus 14, 34, 114, 65. When I divide this synthetically, I had better get a remainder of 0 because it is a root, a 0. So I will bring down my starter of 1. 1 times -1 is -1. That gives me -15. -15 times -1 is +15, which gives me 49. 49 times -1 is -49. If I subtract here, I'm going to get 65. 65 times -1 is -65, and just like I expected, I got a remainder of 0. Now this represents the depressed polynomial. I don't need to write it down, but it is 1x to the 3rd minus 15x squared plus 49x plus 65. What I'm going to do is write it down: 1, -15, 49, 65. Don't write the remainder, just the depressed. And the reason I'm going to divide by -1 again is because it was a double. So it is a repeated 0. I can use it again. If I had numbers like -1 and -7, then I would try -1. I would depress it 1 degree. I would use -7, depress it 1 degree. But I don't have -1, -7. I have -1, -1. So here we go. I should get another remainder of 0. Bring down the 1. 1 times -1 is -1. Combine for -16. -16 times -1 is +16. Add for 65. 65 times -1 is -65, and so I did get another 0. This is simply division confirmation of what I saw over here. I have depressed this another degree. I use the zeros that I can determine from the graph, and that will help me depress it. What is the degree of this now? We started 4th degree. This one was 3rd degree. This one is 2nd degree. This is x squared minus 16x plus 65. If I can find the zeros of this, then I will have all 4 of them. I always try to depress the polynomial until it is quadratic, because then whether the answers are rational, irrational, or imaginary, I can find them. I'm going to use the quadratic formula. A is 1, B is -16, and C is 65. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is, I keep needing a little bit more room. This is positive 16 because it is negative of b, opposite of b. So it's positive 16 plus or minus the square root of negative 16 quantity squared minus 4 times 1 times 65 all over 2 times 1. This is 16 plus or minus the square root of 16 squared is 256. I'm sorry, negative 16 squared is 256. And if I multiply these, let's see, 65 times 4, that's 22. That's 260. Over 2. All right, so I have 16 plus or minus the square root of negative 4 over 2, but simplifying that, the square root of negative 4 is 2i. So this is 16 plus or minus 2i over 2. Reduce 8 plus or minus I. I divided 2 in there to 8, 2 in there to a 1, 2 in there to a 1. I didn't need to write either one of those ones. Those are my last two zeros. I have as zeros negative 1, and I actually have it twice, even though I don't write it a second time in the answer block. Then I have 8 plus I, and I have 8 minus I. When you get complex roots, complex zeros, they always come in conjugate pairs. You cannot have a single one. You must have a pair, and they will be conjugates. Why? Because of the plus or minus symbol in the quadratic formula. So in this problem, we graphed it. We could identify visually a double zero at negative 1, but then we depressed with negative 1, synthetic division. We depressed again. We got a quadratic equation, came over here, used the quadratic formula, ended up with comma 8 plus I, comma 8 minus I. I do not know whether MyMathLab will allow plus or minus. Altogether, I can now account for all four of them. This one has a multiplicity of 2, and then one here makes 3, and one here makes 4. Fourth degree polynomial function, 4 zeros. All right. Number 3. I'm going to go ahead and give myself some space right away. Whoops. I cannot tell by beginning this whether I will have that same situation, but I'm ready for it if I do. The first thing I want to do is put it in the grapher. So I'll clear this out, and I have 5x to the 4th power minus 74x to the 3rd power plus 100 x squared plus 218 x plus 39. All right, I'm in that crazy window from the last problem, but I'll just see. This is another 4th degree polynomial function. I'm expecting a w, and I'm sort of getting part of a w. Yes. All right, so if you did not know that fourth degree polynomial functions with leading coefficients that are positive, like positive 5, I expect some kind of a W shape. When I look at this, I see sort of a W. It's certainly not a symmetrical W. All right. I don't need it to go all the way to negative 20, so I will do, negative 10. I'll leave it at 20. Now on the y's, I need it a lot further down. How about negative 500? Let's see. All right, I don't think it's that important that I see this turning point down here, this minimum value. I do know that it is going to look like this, and if I wanted to, I could say that that's going to do something like that. Okay, I don't know how far down it will go, but it will be down there. Let's look right here. The only zero that I can absolutely tell for sure appears to be negative 1. Let me see. I'm going to go to table, and I'm going to type in negative 1 and hit enter, and it'll write over that. Yes, I did get a 0. Now it's crossing again between negative 1 and 0, so that sounds like a fraction. I know that there is a 0 at negative 1. So x equals negative 1. I'm going to use synthetic division. I have 5, negative 74, 100, 218, and 39. Negative 1. All right, bring down the 5. 5 times negative 1 is negative 5. Combine for negative 79. Negative 79 times negative 1 is 79. Combine for 179. 179 times negative 1 is negative 179. That's going to give me a 9. I think it's going to give me 39. It'll be positive. 39 times negative 1 is negative 39, 0, yay. I have the first 0 at negative 1. Now, if I look at this a little further, I believe that I have another 0 at 3. I think I do. I could use my grapher and check it. If I type in 3 and enter, yes. So I know that there is a second one at 3. I'm going to take that 3 and I'm going to divide it into the depressed polynomial, because dividing by the zeros that you have continues to depress it. That bring down the 5. 5 times 3 is 15. That gives me a 4, negative 64. Times 3, well, I gotta see, 64 times 3, 12, 192. And it is negative 192. So I subtract, and I'm going to get, I believe, negative 13. I'm doing some of this arithmetic in my head, so it's a little scary. Negative 13 times 3 is negative 39. Yes, another 0. I think I can tell what this last one is, but you know, this is quadratic now. Remember, it started fourth degree. I identified a 0, divided. Now this represents third degree. I think I identified another 0, so I think I've seen 3 of them. I divided by it, depressed it. This is x squared. Now, 5x squared minus 64x minus 13. I can either use the quadratic formula or I can try to factor it because I believe these are rational, or I can try depressing it. I think I'll see if this factors. I know I'm going to have 1 plus and 1 minus. I've got 5x and x. I'm going to put 13 in here and 1 in here. That gives me minus 65x and plus 1x, which gives me negative 64x. Those are correct. You could be doing this by the quadratic formula. If 5x plus 1 is 0, then 5x is negative 1, x is negative 1/5. If x minus 13 is 0, x is 13. Now I thought maybe this was the 13, and this was our 3, and this was negative 1, but I could not guess what this other one was. And you can't see it real well in this window, but what it is negative 1/5. So our answers are negative 1, positive 3, negative 1/5, and positive 13. You could find all of them but the fractional value by looking at the graph, and so we depressed. Let me just show you something. This is an OR. If you took the 5, the negative 64, and the negative 13, and you believed, oh, I think there's a 13 there, you can depress it 1 more degree. Bring down the 5. 5 times 13 is 65. That gives me 1. 1 times 13 is 13 with a remainder of 0. This is now x to the first. So if you take 5x plus a 1 equals 0, 5x is negative 1, x is negative 1/5. So I found one by looking at the grapher, I depressed. I found another one by looking at the grapher, I depressed. Now that it's quadratic, I stopped using synthetic division and went and found the other two. But I could have, because I saw a third one, I could have used it to depress it one more time and then solved the final depressed polynomial. Those are those answers. All right, let's take a look at number 4. It says an incomplete graph of the polynomial function blah 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 is shown to the right. Find all of the zeros, and then it says without the graphing utility draw a graph. Well, I'm never going to take the graphing utility away from you. What they are hoping that you would do is say, okay, you have given me, I drew this on the picture. You could have counted, it says it's going in the x's from negative 5 to 0. So you have to read these to see. And if this is negative 5, then this is negative 4, negative 3, negative 2, negative 1, and 0. So this is the y-axis. And the the y's went from negative 35 up to positive 35. So this is a little piece of the graph. All right, what do I know about this? This is a third-degree polynomial function. The leading coefficient is negative, so it is going to be up on the left and down on the right. So I'm thinking it's going to look something like this. Well, right away, when I get to it, I know this is going to be my choice. This is up, up, this is up, up, this is down, up. None of these could be right. But I'm supposed to also find the zeros. Now maybe they'll be visible in the grapher. If not, use the one that's given, x equals negative 4. And let's depress it. Negative 4 into, the leading coefficient is negative 1, another negative 1, a 10, and a negative 8. It is third degree right now. If I divide it by one of the zeros, I will depress it to quadratic. So that's negative 1, multiply for 4, that's 3, multiply for negative 12, that's negative 2, multiply for 8, and that's 0. And that's what I expected. This is quadratic because it started third degree way up here, and now I've depressed it to quadratic. I could try factoring. Let's see. Negative x squared plus 3x minus 2 equals 0. I don't like the leading term to be negative, so I'm going to factor out a negative 1. That will give me x squared minus 3x plus 2 equals 0. Keep that negative 1. That's x. These both have to be minus, so it's going to be minus 2 and minus 1. That gives me x